Hello there. This is about my third or fourth attempt at making this video, and they always turn out too long, so I'm going to try to do it quite a bit quicker this time. What you see on the screen behind me is a board out of a Bally Miss Pacman pinball game. And inside this game, there's a little mini digital game where Pac-Man, the yellow dots, chases or gets chased by the ghost, which are the red dots. And somehow you score points by doing something. I've not played the game, so I honestly don't know how that works. But this board is got 25 cells, 50 light bulbs. They're little miniature socketed light bulbs, and they have little rubber cups over the lights to give them their yellow or red color. So Mike wants to replace this board with a digital board, basically an LED board. And there used to be digital boards available, but they are no longer in stock. I don't know if they're going to come back sometime, but we decided that we would try to make our own. And JLC PCB, who is not a sponsor of this channel by any stretch of the imagination, but they have a new surface mount pick and place capability that produces rather inexpensive pick and place small quantity boards. So we decided we would give it a try. So I've been designing a new board that will replace this board using LEDs. So this is a rendering from Kicad of what that board is going to look like. So I've got it basically completely laid out, and you can see that there are 25 cells of LEDs, and if I zoom in on a cell, and I can zoom in on any one of them, you can see that there are 12 LEDs in a circle and 6 resistors. That makes a total of 300 LEDs and 150 resistors that have to be accurately placed on this board. Doing that by hand would be an extremely difficult task, especially trying to get them rotated into circles like this. It can be done. You can calculate the math, figure out where to place them, figure out the angle of the things, and one by one you can place these things on the board. But I discovered that there is a much quicker way to accomplish this task in Kicad using some action scripts that are available for free as an add-in to Kicad. And let me pop over, wrong one, pop over to the website. I'm not exactly sure how you pronounce this gentleman's name. I'm not even going to try. I can't hardly pronounce my name most days. But he has produced a beautiful set of action plugins that include the ability to replicate layouts and place footprints in strategic places. So I am going to show you tonight how we accomplish that and how wonderful this tool, these macros are. I'll call them macros from now on. They're actually Python scripts, but how these macros make this job just so simple that placing the LEDs and the resistors becomes the easy part of making this board instead of the hard part. So let me take you to the schematic first of all so you can see what we're doing here, and I'll try and explain it just a little bit. So these light bulbs are fed by the switched illumination bus, which is a 6.5 volt positive pulsating DC voltage that will turn on the LEDs. The circuits are driven by the standard light bulb driving boards, the light driver boards that are in the Bally machines, and they will ground this input whenever it is activated by the computer. So what we have here is two resistors in series. We have two diodes in series, each of which is dropping 2 volts. So that gives a 4-volt drop across the diodes. And we have 3 of those pairs of diodes in parallel. Each string will draw 20 milliamps approximately. Actually, it's about 15 or 18 because of the resistors, but maximum of 20. So you have a maximum of 60 milliamps that will be drawn through these 3 circuits. These 2 resistors are placed in parallel. They're 100 ohm resistors. Putting them in parallel will give you 50 ohms, but it'll double the wattage and help dissipate a little bit of the heat. And then there's just another 470 ohm resistor also in parallel with the diodes, just as a little bit of extra load to make sure that there's enough current being pulled through this circuit to keep the SCR turned on that's driving these things. Unfortunately, you could do this with a lot less diodes, but if you didn't have enough current going through the SCRs, they wouldn't stay on, and you get flickering and kind of a ghosting look and things like that. So you have to have enough diodes to keep the SCR on. And of course, we have a red and a yellow channel with each channel. So now I'm going to bring up a new copy of this where I just have the one board or one circuit defined. I should, before I do that, let me step up a notch. So the way this board is built, on the main sheet, we define a hierarchical sheet, and all 25 of these cells use the same hierarchical sheets. In this case, cell 1, cell 1. You can see they're all using the same sheet, and that is key to the way these macros work. It has to be done this way for the macro to work. So I'll be back in a minute with a clean version of this so you can see how easy this thing works. Okay, I have a copy of the program that I was just working on. I kept the entire schematic, so it's still identical to the schematic we had before, but I've deleted everything off of the drawing except for the frame, just because I wanted to keep that. I'll actually hide that cut layer for now, just so we don't have to deal with it. So the first thing I'm going to do is just import all my components into my board layout. And here you can see all of those components. Now, because I want to lay out one of the cells completely and then duplicate that to all the other cells, I'm going to delete all of the stuff except for that one cell. So what I need to do is come in here and figure out where the first cell is, and that'll be the one with the lowest numbers. And that would be this one right here. Okay. So that one there I want to keep. I can just go ahead and delete all of the remaining components for now. I can reload them at any time. So coming in here, you'll see all the diodes and the resistors. The first thing I want to do is get the resistors out of the way, just so that they aren't an inconvenience to me. And now I'm going to arrange these diodes the way I need them arranged. So the key diode in this is diode 0. So there's 12 diodes. They get positioned like a clock, you know, so 0 would be the 12 position, and then diode 1 would be at 1 o'clock, diode 2 would be at 2 o'clock, and so on and so forth. And I want these diodes, well, you saw when I zoomed in earlier that they're rotated 90 degrees from this. So I want this rotated 90 degrees. And I also know that the pad that's down will be connecting to D6, so I actually want to rotate that 2 more times. Okay, so now I have this diode, and it is rotated in the position, and yeah, it's like I want it. So now I can run one of the first macros, and you go up under Tools, External Plugins, and I want to do the Place Footprint macro. And I'm going to replace it by reference number. That means that it's going to start with D0, and then it'll place D1, D2, D3 in incrementing numbers as they go up. But I want to arrange it in a circle as opposed to a rectangle or a line. And I needed about 4.2 millimeters spacing from the center. And I say, okay. And there you go. The ring's done. It was that easy. I don't have to fight with it or anything. Now, actually, it's not quite done yet. If you look here, these lines, they should be going straight across. So 6 of these LEDs are actually rotated in the wrong orientation. And I just need, starting with 6, I just need to rotate it twice. And there you go. I'm finished. That's done. And you can see it's nice and clean. Now the next thing I would want to do to get this looking good is I would want to move the references to the outside edge. And I'm going to do this, but I'm going to stop the video and I'll bring you back when I have them all moved to the outside. Okay, I have all the references moved to the outside, and you would think that that's perfect. Now we can just duplicate all of this and it'll look really good. But you remember that these diodes go up to 300 or 299 or something, 0 through 299. And once these numbers get bigger, those references aren't going to be in the right place. So the next thing I needed to do was justify these. And all of the ones where the D is closest to the resistor need to be left justified. And where the number is closest to the diode, where the number is closest to the diode, they need to be right justified. So the way you do that is you just click on it, hit E, and over here on the side, it tells you they're all naturally center justified. So this one needs to be left justified. And it actually moves when you do that. So you have to move it back down to get it placed where you want it. And on the ones that need to be left justified, right justified, you just hit right and hit OK. Again, they still move. And you need to bring it back. So again, I'm going to do this justification to all of these. It'll look exactly the same when I get done, but I'll bring you back when I'm done with that. Okay, now that the justification has been set up correctly, as these numbers get bigger, they won't um, go over the solder masks or anything like that. They'll stay out in the clear area. I do want to point out that I've set my uh, default track width to 0.5 instead of 0.25 because all the tracks in here are going to be exactly the same width. So I figured it was just easiest just to set it there in the default. So I'm going to quickly draw in some traces. Okay, so that's the traces internal to the diode suite. You can see this line on the outside. These are the common 5-volt input. They come in here, go across, go there, and then this will be the switched output. So now I need to arrange the resistors so that they're in a good position. Um, and The easiest thing for me to do for arranging these are, well, before I do that, the 4 center ones need to be rotated 90 degrees. And then yeah, sorry about that. I'm going to be doing the same thing to these references. I'm going to uh, position them. I'm going to left justify them so that as they grow, they will grow out away from the component itself. Uh, Now, when I did my layout, the actual one that we plan to have built, I went in and I edited all these positions to make sure that they were exactly evenly spaced, just because I like to do stuff like that. But for right now, I'm not going to do that. I'm just going to move this over here. This is close enough for this demo. Uh, left justify. Okay, so that's all done. All I need to do is add a few more traces to this. Um, And with that, this cell is done. Now, in about 2 minutes, the entire board's going to, or the entire layout of this is going to be done. And this is the part that's just amazing. So good idea to save it here just so that if something messes up, I got something to come back to. But all I need to do is reread in the board to bring in all the rest of the components. A little slow with all these components on the board. Now let me put them up here. Okay, now is where the real magic happens. So the first thing I'm going to do is I'm going to select this diode 0 again, and I'm going to go back to that same place macro that we used before. Wait a minute. Tools, external plugins, place footprint. But you see here it has, you can place footprints by reference number, and that's what we did the first time using the reference numbers of D0, D1, D2 to do the placement. This time I'm gonna place by sheet number. So what it'll do when I do that is it will take the same diode on each sheet and it will place that. So I pick cell 1 and it'll tell me all the sheets that have the cell 1 equivalent in it. So I will use all of them. And this time I am going to do a matrix. And as it turns out that there's a 5 by 5 matrix and they're 31 millimeters by 31 millimeters. So I pick 31, 31, and I hit OK. And what has just happened is it just placed that first diode. But that first diode is very important because it's the anchor point for the placement of all the rest of the stuff when I duplicate the layout. If I did a rotation where I made these diodes in a sweeping arc, it would do the duplication in a sweeping arc. So right now I got the matrix all laid out, and I can go back and reselect the anchor diode in my main copy, and now I go back to Tools, External Plugin, and this time I want to replicate layout. I pick the sheet I want to lay out, and what it'll do is it'll replicate the tracks, the zones, the text, the drawings. You can have it do some other things too, but I hit OK, and there you go. The board's almost done. So now all you got to do is put the connectors where they belong, get them lined up, do your connections, do a fill to bring the power in, and the board's finished. It's that simple. If you had to do this in a program that didn't have this macro capability, you would have 450 discrete components to place at odd angles and in odd places around the board. The odds of getting it exact would be very, very slim. So again, looking back at this GitHub entry, and by the way, if you go to this GitHub, down at the bottom of the GitHub, there's an explanation of how each of the plugins works. There are other plugins in there that can do things for you. As a matter of fact, here it shows that replication where it replicated an item, and the thing that was copied was turned so that it made an angled copy of it. So there you go. See, he turned it, and now when he does the copy, the whole thing turns. So So that's really neat. I don't particularly care for these animated GIFs because you can't stop them. At least I couldn't figure out a way to stop them where I could study it a little more. But he at least did a really good job of showing this stuff. He's got several other macros up there I haven't even tried to look at yet. But this guy deserves some great credit for doing this because this is a capability that will make a lot of our work much, much easier. So the next thing, I'm not going to take this any farther. The rest of that is just regular board layout, putting the connectors, drawing the traces, getting the fills done, making sure that all the connections are done. But we're going to go ahead and use JLC PCB's pick and place capability. They only charge $7 a board, $7 a project to set it up, and just a few cents for placing the parts on there. But the caveat is you have to use their parts. You can't add your own. You can't. They have. I won't call it a limited library. They have a quite extensive library of parts. But in the next video I make on this, I'm going to go ahead and go through the process of making all of the files necessary to order these things. And I've never done this, so this is a learning experience. I really don't know what it's going to cost, but we will find that out. So thanks for watching this, and at some point down the future, if we get these made, we'll be updating the Miss Pacman pinball game as one of our projects. So as always, thanks for watching, and come back.